Welcome to today's presentation called What's New in Advanced Design 2025, and I will introduce the latest Advanced Design release during this presentation. One comment on the beginning: as you have access to the chat, feel free to ask any questions on it through the presentation, and I will answer them on the Q&A session at the end. But before we begin, let me introduce myself. My name is Mateusz Budziński. I'm a product line manager for structural analysis software at GRAITEC. I graduated from the Faculty of Civil Engineering at Kraków University of Technology in Poland with a specialization on numerical computing methods. I gained my experience as a support engineer and then as a product manager at the research and development team at Robobat. Then, after GRAITEC acquisition, I gradually became more involved in advanced design development management, and now I'm responsible for planning and managing the development of analysis software within the group, especially advanced design, of course. In today's presentation, I grouped the novelties into 6 categories: computing capabilities, modeling capabilities, steel design, timber and concrete design capabilities, and at the end, improvements related to the user experience, but not only. On each category, we have many novelties, not only visible on that slide, so I will present them one by one, let's say. I will start with computing capabilities. The first new feature is the ability to modify stiffnesses of surface elements by using simple factors. By this, we can control over orthotropy behavior, as we can adjust independently all stiffnesses of planar elements. For this, there are new options available directly from the properties of the surface elements. We can edit stiffness using 2 modes. In basic mode, we can enter coefficients separately for different directions of different stiffness types, like membrane stiffness, bending stiffness, or shear stiffness. And for more advanced users, there is a detail mode available, which allows modification of the element stiffness matrix. There are many applications of this novelty. For example, we can use it for changing the stiffness due to the cracking that is different in both directions. But I will show other examples. The first is the ability to model void slabs, so slabs with rectangular or oval hollow infills. Such panels obviously have less weight than solid panels of the same thickness, but also lower membrane stiffness and shear stiffness, but only slightly lower bending stiffnesses, but different stiffnesses. So thanks to simple formulas, we can enter stiffness reduction factors and then analyze the given slab. Such formulas you can find usually on the websites of producers of such systems. And for this example you see on the screen, such formulas, if I'm not wrong, are mentioned also on the What's New document. Another example, we have a building, and for walls marked in red, we don't want to transfer lateral forces in seismic calculations. It's because the red walls are not continuous between the levels. For this, on such walls, we should reduce membrane shear stiffness. Optionally, we can also reduce bending and shear stiffness. This short video presents this example. So there are 2 identical buildings. For red walls, on the second building, we reduce membrane shear stiffness using a basic mode. And then, after calculation, we see that due to the lack of stiffness, the red walls are not transmitting horizontal loads, so the deformations are higher than on the first building. Yes, you see. Another novelty is an alternative method of distributing loads from load area to linear elements. It's called finite element transfer. For selecting a method, we use a new option on load areas having 3 entries: failure lines, which is the previous version, new frame transfer, and auto, which is automatic selection of the best method. How the new method works, in short, a given load area is extracted from the structure. We run a fast final element analysis in the background, and we convert the resulting reactions into internal loads on edges. Thanks to this, the distribution of loads applied to linear elements is closest to reality, and which is more important even, it allows correct distribution for complex load shapes, for which standard methods may give incorrect distribution impact. Let's see 2 examples of a very basic layout of a rectangular load area distributing loads to all edges. First, we see the case of uniform load. So the automatic approach gives us a typical envelope load distribution. But if you impose the FEM type distribution, it gives us a similar layout. So for this example, there is no big added value if we impose the new method, so we can keep the auto. But in the case when the load is more complex, has a variable value, or is applied only on a part of the load area, the automatic method will choose a new transfer method, and we will see that it's close to the real distribution. While if you impose the standard failure lines method with averaging turned on, it gives us inaccurate approximation on the load distribution. That's why for that complex loads shapes, it's always better to either use the auto or impose the frame transfer method. And again, short video. It presents a beam system with 2 load areas. We activate new transfer mode, and we want to distribute loads in one direction only. We can see loads applied on the parts of the load areas, different variable values. And after the calculations, we will see how loads are applied to beams. Yes. The next point is related, the next chapter is related to the modeling capabilities. So with this release, we introduce a new generator for photovoltaic panel support structures. The generator allows for modeling 9 different types of geometries that are applicable across various types of projects, including large-scale solar farms, residential rooftop installations, or carport structures. So the generators can be also used to model conventional canopies, but the main aim was to model structures for solar panels. There are 9 new generators and all easy modification of most parameters, making the tool very flexible. For example, columns can be inclined. We can add additional bracing between columns or rafters, and so on. We can change also our other settings, like we can decide if you define punctual or linear supports, if the load area is generated, and separately for columns, rafter, and purlins, and also bracing linear elements, we can assign predefined step design settings, materials on different sections. Again, I will show you a short video showing the process. First, we select one of 9 predefined types. Then we enter basic geometry parameters like the slope or the height, clear height. On next tabs, we can change settings for columns, for purlins, materials, sections, and also support conditions. Now, we can also save the data as a template for the reuse. And finally, we get the generated geometry. Okay, the next point, the next novelty, is a possibility for the display of foundations visualizations on 3D model. to this effect, for the selected supports, you can set that they are foundations. This way, you can see that you can see the real dimensions of these foundations when displaying the render views. Basically, the dimensions are based on the values available in the support properties. In general, it allows for better presenting models for preparing nice documentations with foundation dimensions. And thanks to the new extended bidirectional data exchange with the RC Fusion module, we can exchange much more data related to geometry, including the eccentricities of type of the pedestal. So we get more info related to the real foundation shape, and thanks to the graphical presentation, it makes it easier to control the model. And yes, let's see a short video where for selected supports, we activate the new option that should be treated as foundations. Then this allows us to edit the dimensions and display their geometry. As we can display foundation geometry, we can prepare simple views from foundation layout as you see on the screen, just an example. Another new feature concerns data tables. First, we can add new linear and point elements directly from the table. So there is a new button that adds a new line, and we can enter the data to create new elements like linear elements. What's more, new elements can be also added to the model by importing from Excel sheet. As shown in the image, we can export, for example, a part of a building to Excel, then add existing objects or edit existing or add new objects to the in a spreadsheet, and then import all into the model. This opens many possibilities. For example, we can prepare our own generator of typical geometries in Excel, especially if someone can create their own macros in Excel. And again, yes, there is another video to show this process. It starts from opening the data grid table and export it to the Excel file. In this example, the model is empty. Next, using prepared earlier Excel spreadsheet, we can generate data for new geometry. The table content is copy and paste to the exported previously spreadsheet, and finally, the table is imported back, and the geometry is created. So it's just an example how we can reuse this functionality. This slide presents 3 other small novelties related to model creation. The first is the creation of rectangular surface elements using 2 points. So walls, slabs, or load areas can be defined just by using 2 points on the diagonal. This is small but very useful feature, as modeling, for example, walls, just 2 clicks is just quick. The second novelty I wanted to mention is the option to bidirectionally convert a planar element to load area. So having any planar element, by using this option, you can convert it into the load area, or in the opposite way. The geometry remains the same, but other not common settings are set to default then. It's useful in many situations when we change the concept, for example, or sometimes after import a model. Another new option is related to load according to Eurocode. Now we can consider that a given roof slope is protected against sliding of snow, like when using different kinds of fences on roofs. On the interface, it's just an option on the property list of load areas. It affects the generated loads on such roofs, as well the snow load from sliding on lower roofs if exists. Now we are going to the steel design capabilities, and the first point is that with this release of Advanced Design, we introduced the ability to model parametrically 9 new types of cold form sections: double sigma, back-to-back, and front-to-front. New types of C profiles, including ones with the slanted top flange, usually used for modeling if purlins. And there are also new double C profiles with one fold or with two folds. All such new sections can be now modeled, of course, parametrically. And what is more important, we can not only model such profiles, but we can also do a verification according to Eurocode 3, as well according to American AISC standard. Yes, in the video, we see first cold form sections we are able to model parametrically so far, and then next 9 new ones. We can see that all new sections can be easily defined parametrically. So when we select one, can see all that parameters we can edit and create new section according to our needs. Yes, and then all such new sections can be verified according to the code, which is really nice because calculating some parameters for a special double section is not easy. So you can do all that checks according to Eurocode and or American codes. Another new feature related to viewing the results of a standard analysis for steel sections. It's as you probably know, all steel verifications are performed on a given linear element on many points along this element on different mesh nodes. And by default, the results for select element in the shape sheet are presented for each verification as decisive from different locations along the member. So from different mesh along the element. Now we can also see the results from any selected mesh node along the length of the element. So if someone wants to check all the results coming from the start of the element, now it's possible. In addition, if multiple elements are selected when opening the shapesheet window, then it's now possible to easily switch results for individual bars directly from the window. So without closing the window, we can see results for 1 second and other element that was on the selection before opening the dialog. And again, there is a short video. So in this video, we select 3 steel columns to see the maximum work ratio. Then we open the shapesheet dialog, and now we can easily display results for one of selected columns from that 3 ones. And we can also check all the results separately for each mesh node along that element. So we have just more info for each element thanks to this. And now about improvements related to steel connections, and more specifically to the steel connection module. I'll mention 3 improvements to the welded tube truss connection. First, we introduced the possibility to define additional reinforcing plates, which can be defined horizontally or vertically on the truss cord. Such plates can be welded to the top flange or a web of a cord made of I sections, or welded to the top or side wall of the cord made of the rectangular or square hollow section. Of course, all the verifications are also performed according to that reinforced plate. Another novelty is the addition of punching share verification to this connection. So this expands the available verification types for that connection. And finally, we can now generate the drawings for this connection type. As it was the only one connection type that we are not able to do the drawings, now it's possible. On this video, we see that one of the checklists failed. And when we add a horizontal reinforcement plate, then we do the calculation and we see that the checks are passed. And we can also see the drawings. So we can easily generate drawings for this connection type. Of course, they are just not very complicated drawings, they are just simple drawings. But we can export them to AutoCAD if we need. Now it's time for timber design capabilities, improvements on that area. So Advanced Design 2025 is not able to design single tapered beams according to Eurocode 5. So tapered beams are rectangular in sections with a linear slope from one side, top or bottom. So slope, and are made usually from glue laminated timber. The rules for design are described on the paragraph 6 of the Eurocode 5, and in short, during the calculation, special factors reduce the some strengths, like the bending strengths. The next improvement related to the timber design is a significant reduction of the calculation time of the timber elements when we do the verification according to Eurocode. Thanks to multiple optimizations, the engine performed up to 70% faster than previous versions. It's great. As you can see from these examples, regardless of the size of the project, the acceleration is significant. Minimum 2 times faster, but usually 3 times faster. So it's really nice. And I think everybody will be happy with that. For verification of timber elements according to Eurocode, there are even more improvements. First, there is now a possibility for timber elements to run the optimization per system, so which will make the process easier to manage, in fact. Another improvement is a possibility for selecting for graphical post-processing additional results for deflections. So we can display different additional results on the directly on the ribbon. And finally, for French users, we implemented additional deflection checks according to the French National Annex to Eurocode 5. Now we switch to concrete design capabilities. I will start with the performance improvements. So thanks to optimization of the calculation code, the calculation time of reinforcement for surface elements has been shortened. The degree of the reduction depends on the example and on the standard also. This can be especially visible when calculating according to Eurocode, but also for other codes, the improvement is visible. So for all planar elements, walls, slabs, you can see the time reduction. Another new feature is the ability to edit a Young modulus values for reinforcing steel. In Advanced Design, this editing takes place in the properties of reinforced concrete zone, the material dialog. This, thanks to modeling, thanks to changing the Young modulus, we can simulate non-standard types of reinforcing steel during the calculations, such as stainless steel reinforcement, or to a limited extent, also composite reinforcements as well. Changing the Young modulus for the reinforcement affects especially cracking and deflection. So you see on the picture on the right, we have 2 beams, one with reduced Young modulus, and the crack values are bigger on that one beam. The next novelties In fact, all the novelties I will present, I want to mention today relate to the RC design modules. The first new feature is common to all RC modules, and it's the ability to transfer detailed reinforcement information from bar schedules directly to the Excel sheet. For this, you can use a new command from the properties of the reinforcement table. And as you see on the example, not only descriptions and values are transferred, but also bar schemas. Now I'll switch to novelties to the RCB module. The first one is that in case we want to generate the bending details and drawings, then for elevation view, we can decide if top reinforcement is separated and it's generated over the beam elevation. So we can generate bending details below the beam, or top bars can be separated and visible above. The next improvement is also related to drawings. We can now define sections not only along the clear span of the beam, but also on supports. Let's look on the video. First, we get the reinforcement on the beam and we generate a drawing. Then we add a new section to the second span and we can place this section in the middle of the support. For this, we can enter the negative value here. Yes. Next, we add bending details, and then we activate the new option to see bending details over top for the top bars over the span. And finally, from the reinforcement schedule, we can export the table content to the Excel. So we see now the content on the Excel. We can do some additional calculations and summary using the spreadsheets. For the RC column module, we implemented a set of small improvements related to the fire verifications, including displaying on the info panel a set of additional results coming from the fire verifications. Also, there are some additional warning messages, and there is also a verification of the minimum cover value. We can also see additional rated information in the report. For the RC footing module, we had the ability to perform preliminary sizing for continuous foundations, considering limitations to the wall eccentricity and the width of the path in each side. So this enables better optimization of the shape, especially with the restrictions to the foundations of the next building. For the RC slab module, we provide two improvements. First, in fact, the comfort of work has been improved by significantly increasing the speed of the module, especially when we define reinforcement zones manually, and especially for models with many finite elements. So for the bigger slabs, now everything goes smooth. And second novelty are several updates for addressing strip generation for RC slab, including possibility for automatic strip definition in accordance with the American ACI code, where the width of each strip on each span can be different and depends also on the span length. The next is a possibility for automatic definition of strips along structural axis and not only along the columns as it was before. And finally, we can now edit segments of strips, so we can easily adjust the strip geometry separately for each span. And there is a video for showing this. So on this video, we see that the slab is opened with the RC slab module. Then we open the settings, and there are new options for automatic strip definitions. First, we generate automatically strips using the new rules where the width can be different per span. We can also see how to now we can easily edit the strip for each span separately. Then we choose another options for the strip generation and regenerate the strips, this time with the strips with constant length along the strip. Based on strips, you calculate the reinforcement, you can see the reinforcement or the details, and of course, finally, you can get drawings for that slab. Yeah. And now we jump to masonry wall module. So starting with this release, it enables perform verification of masonry walls that includes reinforcement. We can define the areas of vertical and horizontal reinforcement and set different arrangements of vertical bars. In addition, there is also a possibility for performing verification of confined masonry walls, for which we define the reinforcement in confined elements. In a short explanation, confined masonry walls are structures whose deformations are limited by adjacent concrete structure and are not the same as masonry infill in concrete frame. On frame masonry, the reinforced concrete frame is built first, followed by the infill, and the concrete frames need to carry the load. In the case of confined walls, the order is reversed. The walls are built first, and that, thanks to proper joints formation and reinforcement, the masonry walls also carry the loads, including seismic loads. So on this video, we see a masonry wall, which is calculated, but some checks are failed. Next, we'll see new reinforcement options and parameters related to reinforced masonry, with different kind of vertical bars arrangement. Finally, the confined masonry option is selected, and we set some parameters. So after the calculations, we see that there is some impact on the results. All checks are passed on this example. Finally, I'll present a number of improvements that makes work faster and easier, but also other novelties that were requested and expected by many users. First, thanks new commands on the right-click menu, we can quickly display objects identification numbers and also load values. These make it faster and easier to manage the display of components, because now that options are just under the right click, so we can access them easily and fast. The next improvement is related to displaying planar loads, for which we can optionally fill surface by color. So it might be helpful both when working and when create the documentation, especially to present the loads in a top view. The next novelty is available on the project browser, and it's a possibility to easily sort the elements in a system using different criteria. So when we model structure, we usually define beams, columns, other elements, and at the end, if you want to sort them, you can now use that new sort options and sort according to the type, and then by ID according to ID, and other methods. Yes, and the next, another improvement is the definition of selection templates. Now selections can be saved directly from the view by simply calling a command from the right-click menu. So again, it's possible by using some dialogues, but now using right-click menu, we have fast access for saving selection template. So if we select several elements, we use that option and we can reuse that selection in the future. The next point is related to reports. So far, the report generator mechanism was based on the RTF format, which is further displayed or converted to other formats, including doc or docx. Unfortunately, limitations of the RTF formats, such as lack of compression, sometimes results in the inability to generate a report when the RTF file is larger than 500 megabytes. That's why an additional parallel mechanism is introduced that allows you to define content directly using docx native report file. What does it mean? So such reports are generated directly on the Microsoft Word. So you need, unfortunately, install the Word, but the process is really fast and the quality is really good. A new mechanism can be selected in the report configuration window. In fact, this new mechanism breaks many limits we had, so in the future we can expect next improvements on the reporting. I don't remember if the default is the still RTF or new docx, but anyway, the settings are available on that documentation properties dialog. The next option, starting with this release, we can easily access from the ribbon to some frequently used post-processing options, including options for displaying colors and also display modes for diagrams. Let's see it on the video. We can see that there are we see new lists next to final element results to select display modes separately for supports, linear or for planar elements. So it's much faster than searching display modes on a setting dialog. See also that when selecting any diagram, there is no need to press post-process button. Diagrams now are displayed automatically. Also, when we can also change easily the colors for values directly from the ribbon using the options from the ribbon. Yes. The next novelty is related to keyboard shortcuts. Now we can easily open a special dialog where we can configure custom keyboard shortcuts in Advanced Design environment. You can check the current mapping of keyboard shortcuts and add your own. Note that all the existing shortcuts are working, and we cannot change them, but we can add new ones or add additional shortcuts to existing ones. The next improvement is related to the results tables. Thanks to new options, we can easily see the extreme results for elements. So it means if we have some, for example, as on that picture, linear elements and internal forces for that linear element, we can display only that load combination that are decisive. So that gives them maximum and minimum value of each internal force. That values are displayed in red. Let's see it on the video. First we display a table with internal forces for a selected element. So we see results from all combinations. Next, we prepare a new template when we display that envelope results. So when displaying again internal forces for the same element, we see only results from combinations that gives minimum and maximum values. So such extreme values are in red then. So the table is shorter and we can see the most important results for that element quickly. Yes, that's all for today. You will be able to find more details in the What's New document, which will be available with the setup of the new version soon, in the first days of July. Thank you for your attending. If anyone has questions, please enter them into the chat and I will do my best to answer them. Thank you and have a good day.